By way of introduction, we're very happy to have Matt Benoy here. He's a volunteer researcher at BOM, Bureau of Meteorology. He's been doing it for 20 years, right?
Yes.
And he's just won the 2008 SA Senior of the Year award.
But I'm feeling that.
And he's feeling it.
Yeah.
So without further ado, let's give him a big hand. Thank you.
And as I said, no uni essay jokes, please. Spent 20 years lecturing at the School of Management, so you guys were always just over that line that we never crossed.
You're one of us now. You've been assimilated.
We always thought it was the other way around. Uni essay had the money because they had all the foreign students in the day, but anyway, it's an endless argument. Now, look, I'm not a meteorologist, obviously, so I don't want to disappoint any of you. We're going to go through a bit of a romp in history, which certainly some people will enjoy seeing. And then we'll tackle a little bit of the science as well. So there should be a bit for everybody here. I took early retirement and realized that sitting at home, drinking beer and watching football wasn't going to last very long. So ended up back in employment with government, which was all lots of fun until you realized that everything you did, about every 3 years, the tide would come in and wipe it all out and start over again because it was a new government. So I eventually pulled out at the age of 57 and just looked for something to do. And they were actually running a project at the Bureau of Meteorology, writing a history of flooding in South Australia. When you think about it, what easier job could you have than writing a history of flooding in the driest state and the driest continent? But they actually identified floods all the way from 1838 till the present day. And what was the value of that? Was, well, where can we build houses on the floodplain in Adelaide? When was the last time you remember a flood in Adelaide? It basically just disappeared if you think climatology. The last major flood we had was 2005. Now, either they've got things right or our climate has changed. But again, I'm not a climatologist, I'm not a meteorologist, I can't say anything about that. So once that project closed down, I had 2 years of it. I then said, well, what are we going to do now? And I spoke to a senior meteorologist, and the lady said that, look, we've got all of these journals that are sitting down there that are just rotting away. And somewhere along the line, somebody's going to throw them out because they're in Adelaide, they're not in Melbourne, which is where the headquarters are and so forth. And after all this history, meteorologists are used to looking forward, not backwards. And that's my theory anyway. So their interest in the historical record is really, let's say it's not well curated. And until recently, there hasn't been a reason to have it well curated. But of course, now with climate change, knowing what past weather was all of a sudden becomes important. So we had this project going, and 20 years later, we're finally closing it down. It's been an odd relationship. I've been what's called a long-term visitor. But I'm now actually in a position probably know more about the roots of the BOM in South Australia than anybody else, because all the others have retired and moved on. And of course, now we've got an eclectic team of people who report all over the state, and there's no real sort of local regional office anymore. So as I said, I've been working for 20 years now. Let's see if we can get this mouse working. And we haven't cost the BOM anything, but as you could tell, they provided us with room and IT, and that's really all they needed to do, and they left us to get on with it. And I tell you, it's the most perfect form of work. You can go in any direction you want, as long as you obviously stay within some sort of bounds, but nobody tells you what to do or in any way sort of judges what you're doing. We had two core processes, and that was that these folios that were around, from the heart, it was saying, look, this is history. You're getting on a bit. You're beginning to develop an interest in history as you get older. So why don't we just image these so that at least if somebody does chuck them out, we can have them stored somewhere on the web. They'll never disappear. So we imaged the documents, but we'll get into that, and the digitizing comes later. Our project list was, as I mentioned, the history of flooding, and that book actually exists. Yeah. And then we were told about the Todd weather journals, and we got stuck into imaging them. And that went from 1879 to 1909. Charles Todd, do you know anything about him? Anybody?
Yes.
What did he do? What was he well known for? It's incredible. You know, Australians are terrible. They really are. I learned about Charles Todd literally in grade school in Montreal. And I talk to people of my generation, and you get this blank look, and they might say, well, Todd River? Yes. Alice Springs, Alice Todd and his wife. Anything else? Overland Telegraph, ever heard of it? Australia's first, quote, internet, which it wasn't really, but it connected Australia to the rest of the universe. That was Todd. Not only that, you guys talk about Bragg, don't you? Who brought Bragg out? Todd. Todd only ever went back to England once. He interviewed the person they were thinking of bringing over here to start physics as a discipline, University of Adelaide in the 1870s, 1880s. Turned out he was a drunk, so they picked up a junior guy called Bragg. And Todd was standing in Port Adelaide when Bragg arrived on the sailing ship, and he brought his daughter with him, his eldest daughter, who Bragg married. And so therefore, Junior Bragg, who really was probably the one who did the work to get that X-ray crystallography father and son combination getting the award, that's actually Todd's grandson. And that's being used on the Mars rover at the moment to analyze rocks. So I like to say that Todd's genes are actually now scampering around Mars. That's how close our history is, really. So we then found, after we finished the weather journals, that Todd retired in 1905, and the people he trained, the last one I think retired somewhere around about the late 1940s, carried on his tradition with weather journals. So we found a whole bunch more weather journals. We then found the official Adelaide log books, which logged all of the data, certainly a number of them, sitting behind the barbecue equipment at the old offices up of the Bureau back in Kent Town, just gathering dust. And then we got into doing the lighthouses, and we'll come up with a reason why we did those. And then we ended up having to look at some of this stuff. And yes, it's really nice, pretty as an image, but the important stuff is the data that's recorded there. And that's when the science cut in, and we'll come to that story in a minute. We ended up with 110,000 images. In other words, basically 110,000 pages of meteorological records. And we actually got a graduate from here who did his PhD in mathematical physics. He'd retired, and he did the programming for us and set up our image portal. And I'll be handing out how to get onto that portal. And you can trace our weather from 1836 up to 1957 daily based on those images. And that's available over the web. And since nobody was telling us what we could and couldn't do, we obviously got very interested in Mr. T, Mr. Todd, and we've done a lot of work with that. We had another one of your well-known people, Reg Coots, who we worked with on Todd, especially with telecommunications. And I've currently got an artificial intelligence team coming from the UniSA campus up at Mawson Lakes, doing an AI application for us. And we also did some work on the Overland Telegraph and a whole bunch of other stuff as well. So, Mr. Todd and Mr. Coots. The Todd journals, 65 volumes, and that's what we had in front of us with 25,000 pages in total. And there they are, already packed up to go. In this case, we actually managed to convince Melbourne that these are national heritage, and they've taken them on board. So we shipped that off to Melbourne after we did the imaging. Typically, when you open it up, it's not really replete with data. It's got typically a synoptic chart. News clippings, you can see the synoptic chart down the bottom left-hand corner there. That's the one from New South Wales. And then to the right of that, there's a small map, which is from Victoria. So they'll get the newspapers come in. This is 1880s, probably about the 1884, 5. So they clip the newspapers, and you can see the columns of data there. And it's that data that we ended up digitizing, but we'll get to that story in a minute. On the other page, there'll be further news clippings, there's handwritings you can see. So it really is a sort of a day-by-day journal, except Sunday, because of course nobody worked on a Sunday in colonial times. And you get a narrative of Adelaide's literally daily record of weather. So 65 volumes, 25,000 pages. It took us 3 years. We built the team, learned the business. And when I say learned the business, we actually had to debind those characters, those volumes. Otherwise, you'd end up with them with a fold as you open it up. And we wanted them flat. So we actually made a business case to debind these wonderful books and image them. And we talked to State Library, National Archives, and National Library, and so forth, and went on the web to find out how to do it. And we knew we needed a camera bed, and a camera bed was going to cost well over, I'd say, $5,000 to do the job. So, being Australians, we debound, and there's our camera job. What do? We went to Bunnings, right? We bought all the bits and pieces, and we put one together, and you can see the camera's just screwed up the top there, and you can actually automatically drive that camera from a computer while somebody's flipping the pages. You can take the images and so forth. So each one of those images then had to be straightened, recolored, cropped. We A3 scanned any of the newsprint we saw just in case we wanted to do OCR on it. And in some cases, the papers were folded on top of each other because it was all newspaper piece. And they had to fold them so that they'd all fit inside. So we had to unfold them, take images and stitch them together. Bless the Germans, they actually designed a package that allowed us to stitch images exactly as we wanted to do it. And there's a great Queensland floods of the 1870s, 1871, 72, I think it was. There are literally 11 pages of this newsprint. So what I'm getting at is we're not just talking about data, but we're also talking about narratives. So each of those images took something in the order of 5 minutes per item. And one of those guys is actually dead. That's how long we've been going. Died on the job. The very first synoptic map at a continental level that we believe was ever attempted, you're looking at it right now. And that, I think, is 1879, is it? Yes, 1879. Now, you can see that a lot of it is dashed. The bottom right-hand corner has got a lot of lines on it, and that's because the telegraph systems at the time were working. And of course, to do a synoptic map, you need to get your data all taken at the same time and then taken to a single point where somebody can then put those points on a map, draw lines where there was equal barometric pressure, and that gives you the highs and the lows and the movement of the winds and so forth. But looking at that, you realize what happened in WA, right? Nothing. Well, they only got the telegraph and hooked up 2 years prior to that. It was 1877. What makes it work, we'll see in a minute, is the overland telegraph. And there's not much coming from Queensland either. So either the telegraph system wasn't working then, or they didn't have enough images. But there's the first one now that covers all of the areas. Now, I've never seen a weather system like that, so it's very much experimental. So they were working with very sparse data, and you'd think that that came out of probably the observatory. Does anybody know where the Adelaide Observatory was?
Yeah, on here in Adelaide, next to Adelaide Boys High.
Yeah, is it Boys High or Girls High?
Well, what was Boys High?
It was Boys High, exactly. Yeah, and now it's Adelaide.
Adelaide High.
Adelaide High, exactly. So that's at North Terrace. North Terrace and West Terrace.
On West Terrace and Curry Street.
Yep.
Yeah.
Near the new hospital.
In the beach road or whatever.
Well, you know where that was drawn, that map? Basement of the GPO.
Uh-huh.
Because Todd needed to be close to the GPO because at that stage he was running the post office. So he started doing these when he ended up with an offsider who could help him do it. There's the same map, but done to actually show the public. Okay, so there's the draft. Now, if you look at it, actually, that covers quite an area. But there's how the maps start with, that I call the angry map. Todd obviously got out of this bed to the wrong side, took umbrance at what his offsider had done in the basement, and decided that it had to be changed. And the map below is the one that actually got published. But what I'm showing here is, the creative process. When time is of the essence, you got to get the data in, map it, and then put it up on the day that it actually happened. There's the very first map that went up at the GPO. And this is a story about science communications, getting across to the public. Now think about it. If you're a Victorian, and we're looking here, at 1882, the fastest you could go would be riding a horse. The vast majority of people have probably never been on a galloping horse. What Todd was able to do by putting up these maps, and he put up 6 of them, is you could actually trace that high coming through. If I ask you right now, where do you think that high is going to go to next? It's in the Bight at the moment. Where would it go to next? Victoria, right? And probably through to possibly New Zealand. Where did it come from? It came from WA, right? Believe it or not, they actually believe that weather went from Sydney to Western Australia. And this is Todd's offsider in a paper he delivered to the American Academy of Sciences in Chicago in 1915. He said, we could never figure out why they thought weather went that way, because even the northern hemisphere comes from the west and goes to the east, except for the fact that Sydney was more important than Melbourne. Melbourne was more important than Adelaide, and Adelaide was more important than WA. So anyway, they were able to prove, obviously, with synoptic maps where they went. So if you're a Victorian, weather was something that happened literally in your neighborhood. It fell on your head, and that was it. You had no ideas what was happening on Kangaroo Island. They had their weather. The guys up in Melbourne had their weather, and anybody in between had their weather. But there's no reason to believe they're connected in any way. It just depends on whether you got a cloud over your head. So to actually see this weather coming through and moving on as far as New Zealand just changed the Victorian notion of space and time, that something could start in WA and literally 48 hours later or 24 hours later, it's hitting you, moving on to Melbourne, and a couple of days after that, it's in New Zealand. To go from Perth to New Zealand was probably about a 1-month voyage in a sailing ship. That's how your brain thought about this stuff. So to see this happening in a matter of hours would have blown the Victorian mind. So that was Todd getting the message across.
Sorry, I got a quick question on this. Is all you've got are those actually synoptic maps, or do you have the underlying observations that they drew the maps from?
Yeah, I didn't have the first slide. This is a story of history from the heart, which becomes science from the head. So we'll get to that in a couple of minutes. So there's actually, out of the newspapers, by the way, there's a picture of the old GPO. Can you see in the bottom right-hand corner, there's a cabinet there that says weather. And they used to post the maps up the GPO right up until the 1960s. You still got guys alive who remember going down to the GPO to put them up. Okay, there's an intimate connection between meteorology and communications, and it's all about data. Okay, so if you've only got, and this is one of the early maps, if you've only got data from the southeast corner, you can only make the connections of the southeast corner. Now, Todd put in the Overland Telegraph, that's what he's known for. And they thought, well, obviously he was interested in connecting us. He was running the telegraph network in South Australia. He was running the GPO. He was a man of communications. He obviously wanted to connect us with Europe. But I know that he must have had in his mind something else. And that is that if you put in the Overland Telegraph and you train your telegraphers to do basic recording of meteorological information and sending it back to Adelaide, we can start connecting points from the East Coast that go through a similar pressure point on the Overland Telegraph, join up with a pressure point just off to the left of the Eyre Peninsula, and we can start to have a look at what the weather is. So why don't we connect all of them and see what we end up with, right? And why stop there? Because New Zealand is sending us information through the undersea cable, so we can connect up with New Zealand. So here it is in the 1880s. We got Todd sitting in the basement of the GPO, or Todd's offsider sitting in the basement of the GPO, drawing maps which are basically as large, and I'd argue actually by a few kilometers, even actually larger than any other meteorological service anywhere in the world. So if you looked at the bulge in WA and said that's London, the north end of New Zealand would be the equivalent of probably the Bosporus Canal. Now, to ask a European back in the 1880s to be able to draw that kind of map, absolutely impossible because there are just too many groups involved. They didn't have the telegraphic communication and so forth. So we had some of the largest maps coming out of Adelaide in the world. We then discovered that it didn't stop with the Todd annuals, but it kept on with those who followed him. And we ended up with 12 pallets, 65,000 images. Thank God I drive a van because I remember going up north of Adelaide to a private place where they store these sorts of things. They put a whole pallet in the back of my van. I go back to the BOM and I carry each one of those in individually. And then the next day we'd sit down and we'd start imaging them. So that kept us pretty busy. 65,000 more images and still no data of any size, put it that way. At that stage, we did get a National Library grant, which was really nice. We were able to buy ourselves a very fancy camera, and we started imaging them. Apologies for that rather embarrassing photo, but that's the only one I could get of how big they actually became. So they started out as sort of like A3 size, and they became bigger and bigger, just to show you again what was happening back then. There it is sitting out there. So there's one of us who's actually sitting there flipping the pages. And there's a second person who's driving the camera and putting in the specific identifier, what date and what time was that page that we've done. So there's an example now of a map from the 1950s. Now keep in mind, this is still now, this is probably actually happening at the West Terrace. They've moved out of the GPO by then. They're into a proper environment. And when you look at that map, this is an Adelaide map. You can see down the bottom that we have Macquarie Island. We have an offshore ship, and there's one offshore as well, using wireless telegraphy. And then we've got another one way up north, off the north side of Papua New Guinea. And then the one on the right, I've never been able to actually figure it out, but I think it's Fiji, but I also think it is the other side of the date line. That map covers 105 stations, covers 18% of the globe, and that map was being done 6 times a day. I actually met a guy a couple of years ago who remembers being the person who got this data and copied it onto maps. In there, I'd hate to think, but there must be literally 1,000, probably close to 1,000, or certainly 600 or 700 bits of detailed data on that map. And that was happening 6 times a day. So at this stage, we started feeling rather like, we've had enough, guys. And the lady upstairs said, not so quick, Mac. We just had an ex-Adelaide guy come through, and he's talking about recording old weather data, a guy called Rob Allen. And he used to work for CSIRO, and he used to work for the BOM, but he left in the year 2000, went to the UK, and started a project, which then became From the Head to Science. Now, where are we? Sorry. Rob Allen. And I love this picture of him because he's on an airplane. And that's all he did is he spent about 15, 20 years flying around the world, convincing people to digitize old weather data to act as a backstop for determining climate change. But he also had a friend, Gil Compo, working at Rob at the Met Office, Gil at the University of Colorado, and he was a researcher with NOAA. Rob's business was getting us to digitize. Gil's business was to put it into reanalysis models so that you could look backwards in weather. So data rescue and reanalysis. So this is when we started becoming serious about, well, it's nice to have pictures, guys, but it's got data you need. And this is where the science kicks in. I don't know if you heard of the 20th century reanalysis, but what Gill was doing was unique and still is unique. All that he needs to feed his reanalysis model, and what does a reanalysis model do? It looks backwards. So they take a forecasting model, in very much layman's term, and turn it into a backcasting model. So you use the same concepts you'd use to look forward in the weather, but to actually look backwards in the weather. And if you throw enough pressure data into Gill's reanalysis model, you can go back, and it's something like, I don't know, about a 70-kilometer range around that one data point. You can recreate the weather. And it's not just recreating the weather as we see flat on the ground, but it's recreating the weather in 4-dimensional global atmospheric data sets, right? So, north, south, east, west, whatever, you take a column of air, and his model will tell you what the precipitable water is, what the wind speed is at that height, and as I say, there are 50 tropospheric variables will come out of that model. And you can look at it as 3-hour periods in 75-kilometer grids. So he can tell you what the weather is inside that 75-kilometer grid, okay, over a 3-hour period. Not the details of every minute, but within that 3-hour period, you've probably had X number of millimeters of rain, or the wind speed at, 300 meters is blah, blah. Out of it comes the model. Importantly, includes estimates of uncertainty. And we're seeing that, of course, on the bomb weather side. They'll tell you about the weather. Of course, we always think, well, if they say rain is going to rain, or you don't realize they're saying that it's only a 10% chance. And so his model has actually got uncertainty built into it, so that you can look at it and see what the level of uncertainty is. The model goes, and now, but from 1836, it actually goes from the late 1700s. But of course, that's only based on European, very local European readings. So it's not recreating global weather, it's only recreating local weather in that case. It does this by assimilating surface pressure only, as I said. That's all it needs. It doesn't need temperature, it doesn't need wind speed. All that it needs is pressure, which of course is what is sitting in all of the journals we've just been looking at. And again, for those of you into modeling would understand this, I don't, but it uses monthly sea surface temperature and sea ice as boundary conditions for the model. Skeptical? Well, apparently the accuracy is approximately the same as the current 3-day numerical weather prediction models that we work with at the moment that tell you what the weather's going to be over the next 3 days. So that's how confident he is about what his model is regenerating. So it allows you to re-examine specific storms, flood events, drought events, heat wave events, El Niños, La Niñas. So in other words, it's not just a single event. We can actually talk about climate. By the way, the IOD, does anybody know what the IOD is? The Indian Ocean Dipole? Yeah. You know who was mucking around about the IOD? Yeah, I think we discovered that around about 1972, didn't we? Hogg was talking about it. And the way that he began to see that there was something going on is that he was talking to the fellow telegraphists and fellow astronomers who he had worked with when he was in England. And of course, they were farmed out to, Africa, especially east coast of Africa, into the subcontinent, India, Pakistan, and himself. And they started finding out that when it was dry on the west side of the Indian Ocean, it tended to be wet in parts of Australia and vice versa. And they were actually, presumably, because they had their own access to telegraphy, they didn't go down to the post office and put in a telegraph dear sir. They actually had a telegraph key. And probably in quiet times, they were busy talking to each other. So there's a little bit of social networking for you without telephone. And it led to potentially the IOD, which we now know about. So with Gill's model, you can look at all sorts of areas. Churchill said that the farther backward you can look, the farther forward you are likely to see. Or as we would say, is further forward you're likely to see. So that's what we operated under, is what drove us is we're allowing these guys to look backward so that we can look at climate change and look forward. That's what was important to us. You can even map changes in the way storms develop and progress and so forth. You can get down to individual storms. And when I talk about storms up there, I put hurricanes in small letters because the Americans go absolutely crazy reanalyzing hurricanes of 1922 or 1884 that went up and destroyed half Florida and so forth. And you can actually see these hurricanes develop over time and wind speeds and so forth come out of that model. And Gill's model is, as far as we know, the only model that has confirmed that climate warming is happening without dealing with the temperature record. Because as soon as you deal with the temperature record, you get the climate deniers saying, oh, you guys are fixing the data anyway, because you had to change it from Fahrenheit to centigrade, and you went and fixed it so that it looked like climate change was happening. Well, Gill's model did it just with air pressure. So you end up with all of these reanalyses models that are available out of using the data in 20CR. Okay, down the bottom is Gill's model, but these are some of the other models that are available to you, some of the other reanalysis models. But the big thing about his model is that in this case, it goes to, I think, 1850 was. I said it now goes back even further than that. Whereas if you look at the column, you're lucky if you can get back to 1900. So that was the big change that was happening. That's what was incentivizing us and global teams and Rob to get onto his metal horse and fly around the world trying to get the old data recovered. So with minimal data input, it allows temporal depth, in other words, the amount of time that can be spent. Rob has seeded projects in 16 countries, mainly national meteorological systems, but universities are very heavily involved in finding the data. And he's set up projects around the world, and those are, you can probably read them better than I can, but virtually anywhere you want to think about is covered. We're at the moment trying to get him the IMO medal, which is the top medal you can get for meteorology. And we're hoping to have the UK Met Office put him forward for having put in all of this work. He seeded 16 projects, and the aircraft image says that he did a lot of flying. As a result, he's probably got one of the longest signatures that I've ever seen, and that's what you got at the end of his emails. Whenever he sent an email, you got that as his signature block. So it proves the guy knows just about anybody globally.
What you were going to say, he had the biggest carbon signature of any.
Yes, he is. Hiding in Corfu now. He just decided to get out of the business. Yeah, so he's basically out of it now. And any of you who are interested in the data, it's moved from what we call the ISPD, International Surface Pressure Data Bank, which Gill was busy looking after. And all of that now is being downloaded into Copernicus C3S data. So it's through Copernicus, which you can now pick this up. And Maynooth University seems to be the portal through which you send data. And I've still got something like about 30,000 data points to send through. We reckon that we did 1 million data points. And that's very small in comparison. Probably globally, the project has put in something in the order of probably about 100 million or more data points. Keep in mind all of that's pressure data. So we have a website, and these show that some of the areas that are being picked up as part of the global acre process. So within the taught images, there are numerous data items. In this case, most of them are sort of newspapers from the early taught stuff. And in those days, the barometer readings were like magic and high science, and they were published in the newspapers, as if anybody really cared what the pressure was at UCLA. And actually, at one stage, they started getting letters to the newspaper saying, why is Todd giving us all this pressure data? It doesn't mean anything to us. Will you please stop putting it in the newspaper, which they did eventually. But while it was there, we were able to digitize all of that. So there's just one entry. So you can imagine making sure that all of that's put in. South Coast lighthouses became important. Why? And those are all our South Coast lighthouses. So Rob sent over these emails. Have you got anything on lighthouses? No. What's a lighthouse? Well, you should at least have Tapara Reef. Do they have anything? So off we go searching through National Archives. What's important about the South Coast lighthouses is that, as we know, the Southern Ocean is a major climate driver, major weather driver, not just for the Southern Hemisphere, but globally. And the first knowledge you have back in those days, and obviously you didn't have radio or anything, is when it hit the south coast of Australia. So they virtually digitized. We did all of the ones for South Australia. Rob Allen got a team of students in Germany to do all of the ones along the WA coastline, and somebody, I think, at Uni Melbourne, because the first sign of weather coming through was picked up by lighthouses.
Nice question.
Yep.
So what did you digitise? Did you get a report digitised? Because those guys probably ran barographs. So there would be storages of charts somewhere of the bar.
We've actually got their logbooks.
They would also have kept charts. They would have run a barograph. So that's something else that, God forbid, I'm just telling you, because it's the same as tide charts, because those are continuous charts.
Yeah.
So those things have been a bugger for digitising over the years.
John, isn't it?
Sorry?
John.
Yes.
You're hiding. My ex-boss.
But the barograph would be another source of data.
Actually, it's interesting. Barographs were done for New South Wales. So when you look at the newsprints from New South Wales, they have the barograph.
Sure.
Yeah. No, these are straight recorded, John, and we've just picked up whatever's available.
So don't go away.
Sorry?
Don't go away.
Don't go away.
Yeah, you might get the barographs yet.
No, that's all closed down now.
Yeah.
It's the end of the year and I'm off. Right.
So you don't have a successor?
Sorry? You have a successor?
Yeah.
Nobody's that insane.
It was a
Volunteering for 20 years. Anyway, whatever. No, it's been good fun, but yeah. Actually, what it is, FYI, since I am supposedly Senior South Australian of the Year, get it done by the time you're 80, will you? Because when you're 80, the wheels really start to fall off. And my 80 arrives in November, so I'm getting out before it starts getting bad. By the way, the first undersea cable that Todd put in was to connect Adelaide to Kangaroo Island. And there are only something like about 450 people living on Kangaroo Island. The important thing for him, weather data. Second important thing is you want to know what ships are coming. And you first notice that a ship's about to come into Port Adelaide as they pass there. Why was it important to know what was on the ship? Because you knew that they had stuff coming from Europe that you wanted to buy that you were going to sell to people in Adelaide. So you could advise people that ship X is coming in, and they would know that ship X is probably carrying X, Y, and Z, and everybody would chase off to Port Adelaide to see if they could get the stuff before their rivals got the stuff. Okay. Oh, yes. And they also used actually that weather data to check that the data that we had sent in about Adelaide was correct. Now, again, I can't do the mathematics for you on that, but that's all part of their quality assurance records that they were doing in Colorado as they accepted the data. Digitizing the Adelaide record. Okay, I've got to go through this quickly. Wyatt, as in Wyatt Street, right? But it wasn't on Wyatt Street that he did, as you can see there, between 1838 and 1847. He kept temperature and barometer records, which we managed to find. Kingston, as in Kingston in the southeast, he did rainfall records from 1839 to 1860, and because it was on West Terrace, very close to where the observatory was at the time, Todd accepted his records as an official record and added it to the Adelaide record. So we digitized that as well. And the survey department, wherever the British colonialists went, the people who actually got off the ship, the first things they had to do was to start weather recording. Why was it important? Because what kept the British Raj, if you want to put it that way, or British colonies going was the Royal Navy. The Royal Navy needed to know everything about weather because they didn't want to end up in places where there might be storms, and obviously they wanted to know, what wind speeds were like and so forth. So virtually the first person to get off a ship set up a basic weather observation site, and we actually had the very first one out of Glenelg in 1836, along the lanes. But they set up at the government office, which was opposite the GPO, which is now the hotel next door to the town hall, right, Adelaide Town Hall. And they kept weather records from 1843 up until Todd arrived. So those are the 4 areas that we just talked about that where the observations were done. Todd, though, also kept observation records, and if he's known for anything, it was for this fastidiousness in terms of recording everything. And this started round about, what have I got here, 1876. He could have done it earlier, except they put him in charge of the Overland Telegraph, which only had 660 people in it, which meant that he was running himself a major project. And then they put him in charge of the GPO, which was one of the largest government departments of the time, and then still expected him to do astronomy, which was the job he was actually given when he came out here. That was his job. And of course, to do meteorology. So his annual report stretched from 1876. He couldn't get going until 1876 because he had to reform the post office after 2 robberies. So you run across all of these funny little things telling you why you are getting stats and why you're not. So we have some problems in the late 1870s on statistics. We thought these were absolutely wonderful manuals, and then I found one from Canada, which was same period, and it looked exactly like that, except had the word Canada, Montreal on it. So you realize that the British colonial system actually dictated how you recorded weather recordings. And you could probably find the same in India, in West Africa, and East Africa, and New Zealand. And that's the kind of data that you start looking at. So there's your daily data, your monthly data. And we peeled off all of the pressure data, weather pressure. And you can even see at the bottom there, it contains descriptive information. 500,000 data items alone are on there. Now, we didn't do 500,000 of them, of course, because we just did pressure. We then discovered, and John, it was when you moved into the city, these came across our desk, and we realized that what we were looking at was the 20th century journals that started in 1912. That's the level of detail that's in that one image that's there. We imaged all of those, stitched them together, and put them on the web. And there's one missing, a 10-year period in the 1930s. And we've tried everything. We've tried head office, we've tried National Library. Somebody probably walked away with it one day back in the 1940s or 50s or 60s, and they just never returned it. So we have to go to the newspapers and see what we can get on the newspaper to finish that record. So there's one 10-year period missing, okay. So volunteers, 1 million barometric readings, 250,000 attached thermometer readings, 25,000 rain temperature and other readings. We had to control for outliers, so I wrote in the only language I knew at that stage, which was basic programming. And we would create, so each line you see there is one data point that went to the LSPD. All the rest of it is metadata about that one data point. And of course, literally, there's just pages and pages and pages of this stuff for the 1 million data points we send. Okay. Yeah, I won't bother with that one. Right? Okay. All of this now, and this is the last, we're actually on the web now, is available to you. And let's say if you want to look at the, let's look at the register, which was done by the geezers at the, so again, I'm not too sure about magnifying with this thing, but anyway, let's go. I'm trying to do this. So you can start seeing the data, okay? And indeed, if I turn it off now, I can actually click in here, and then I can move it around and find the data stuff and go back and say, look, I really want to go back home because what I prefer to look at is the meteorological journals. I go to the meteorological journals. and say, well, that's fine, that's the 1st of June 1939, but really what I want to look at is, why have I gone blank? Sorry, guys. I want to do a search. Sorry, guys, I should be able to, and my mind has just literally gone blank, to actually put in the date that I want to see. So if I want to look at the 31st of June, 1944, it will bring up that page for you. Find, there we go. Okay. So what year do I want to look at? Well, I mean, we start way back in 1908 when they started, and we go right through to 1957. So I don't know, let's try 1931. And what I want to look at is, I don't know, October the 10th. Find it for me. And it'll give you the closest that there is. And I can look at any specific date that I want, and I can actually look at what they had to say, what the weather was like. So we put all of these on the web. And again, that's more from the heart. But of course, there's a lot of data there that no matter what happens to those journals, hopefully we'll be finding a home for the digital version of it, which is available for the next load who want to come on board for 20 years and do some more digitizing. So that's it. What I'll do is I'll hand these around. This is how you can actually get to those images. And I warn you, it does not work on a phone because you need a very large screen and will only work on a desktop. So thanks for listening, guys. It's more story rather than hard science, but obviously it leads to hard science. And yeah.
Any questions, anybody? I've got a quick one.
Yeah.
You showed a photo near the beginning of your talk of an enormous pallet of records, and you said they're getting shipped off to Melbourne.
No, that one pallet went, and that was the top pallet.
Went off to Melbourne.
Yes.
And my question is, why didn't it go to the State Archive of SA? Why did it have to go to Melbourne?
It's National Centre.
Because it's partly politics. National Archives, if they can get somebody else to store it, they'll do that because they've just run out of space. They literally have something like 27 kilometers of shelving. And I actually went to National Archives with some of this stuff. And they're saying, look, great stuff, but you're going to have to hold on to it. Right. So at the moment, they're sitting in a warehouse that isn't temperature controlled or anything. And they've now become dangerous because things are falling off the pallet. And all of a sudden, headquarters is taking an interest in something they've never said anything about, because now it's a threatening employees' health. This is not a health and safety issue. It's not a history issue.
It'll get destroyed in the end.
Sorry?
It'll get destroyed in the end because of health, occupational health and safety. It's a cost burden to the Bureau to actually keep stuff. And they're always fighting to reduce the cost burden.
I have hope, though, John, for the Todd collection, which is only a single pallet that has gone to the library.
No, it's bureaucracy, so it's going to get lost.
Yeah, but there are always people that will fight that. Luckily, I got in contact with someone that was about to retire from the Met Bureau, and he sent me all the data. He had the raw data from radiosondes, which is normally discarded.
Yeah, but you need to be aware of where it is.
Yeah, that's the problem.
That's the problem.
Any other final questions? Yep.
Yes, about the capabilities of digitization systems in your experience.
Yes.
So like that text that's up there, for instance, is there some way that you can pass it through a system and you get a reliable record, text output for what that was?
Or two initials, what do you think it is? A-I.
Yeah, but in your experience, is it working now, if you see what I mean?
Yes, and it's just a little bit too late, and I'm hitting that 80-year-old bracket where I just can't learn anything anymore. But yes, I have actually done with those journals that I showed at the end there, where you could float an image. I took a section of it, dumped it into an AI model, and it came back perfect. So mind you, that was very well done handwriting. It wasn't scrawl like that. This was numbers. And then the next one is from handwriting to straight to
Text.
yeah, no, straight to
or voice
spreadsheets.
spreadsheets.
Sorry. But the trouble is, I tried that the other night. I thought, shit, if they can do text, how about this stuff? And it came back into spreadsheets. But it required a lot of setting up to do it. But yes, it's there.
So it's
But you still have to check it for whether it's correct or not.
but it's only been really quite recently. The reason I'm asking was years ago I was involved in an OCR project for defence, but that was a long time ago, and I was
handwritten material you're dealing with then?
No, it was even back then. It was basically typed. But I was just wondering what was the stage of the technology. But you're saying basically it's only very recently that you would feel that you would reliably be able to do that.
That you can do handwriting. In fact, our mates in New Zealand, they were trying to do that. This is pre-AI, probably about 7 or 8 years ago. On every corner they turned, they just couldn't deliver. But now I think AI is going to do the job. Yeah, especially for well-recorded information.
But it requires a whole bunch of people to have kept things and being able, like unbind them, as you were saying, and things like that, right?
Well, hopefully somebody picks up this stuff in the future and does an AI job on it.
Okay, I think we should wrap up here for this time. Thank you very much, Mac. Any further questions, just talk to us straight after. Thank you.